Hi, and welcome to your lecture on absolute value functions. In this first video, we're going to cover graphing an absolute value function, and in the second video, we're going to work on solving them. So make sure as you're going along that you're taking some notes and you're working through all the example problems with me. All right, let's get started. First, let's define an absolute value function. So one way we can define an absolute value function is using a piecewise function. So here's my piecewise function, g of w equals, and these two bars mean absolute value of w. That's what the two bars mean, absolute value. And it's defined to be minus w if w is less than 0, or just w itself if w is greater than or equal to 0. So let's plug a couple values and make sure we understand this. Let's do g of 5. Well, 5 is the second category here, right? It's greater than or equal to 0, so the function value is just 5. G of negative 3, well, negative 3 is less than 0, so that's this top one, right? And so we take the opposite of negative 3, so that would be 3. Absolute value functions always return, the basic absolute value function always returns a positive number. And the way I like to think about it is distance from 0 on the number line. So negative 3 is 3 units away from 0 on the number line. 5 is 5 units away from 3 on the number line. So it's always going to be a positive value because it's a distance. The graphs of absolute value functions generally look like a letter V. So both of these graphs down here are just g of x equal to absolute value of x. We're going to transform them. But I put the originals down for you. So both of these guys are g of x equal to absolute value x. That's what that looks like. So what we're going to do now is we're going to practice using our transformations on absolute value function. So let's try the first one, a. We'll try this one together. Well, let's look at what f does to the function absolute value of x. Well, inside it subtracts 2, and outside it subtracts 3. Do you remember what that means? Well, remember when we subtract 2 on the inside, that's going to be a horizontal shift 2, right? Horizontal shift 2. And negative 3 would be a shift down 3. Down 3, that's what that guy means, right? So we're going to take all this graph, and we're going to go right 2 and down 3. So if we're at 0, 0, we go right 2 and down 3, and our little vertex point there becomes that. Let's go to this point, like right here maybe. Right 2, down 3, and it goes to here. Let's try this one. Right 2, down 3, and that goes to here. And now we can basically just draw this guy in. Wait, that didn't seem like it went quite right. Right 2 and down. No, it did. Okay, and this one's going to go like a nice slope 1 line like that there. And this is going to be a slope 1 line. Trying to do a good job drawing this like that there. And you can see we went right 2 and down 3 from our original graph. All right. Well, we can see we have a couple of things going on here. The first thing that we can see is we're going to be shifting up 1, right? Up 1. That one's easy to see. The negative out here means we have a reflection. And since it's outside the function, it's going to be a reflection across the x-axis. And the 2 on the outside of the function means we're going to compress it in the horizontal direction. All right, so this one's a little more complicated than the other one, and so I think what would be helpful to do on this one so we can make sure we get it right is let's fill out a table of values for h of x and see if that doesn't help us graph it. We know what it basically is going to look like, but this one's a little more complicated, so let's use a table of values to help us. So the very first value in the table that's already filled in is 0, so let's plug in 0 to h of x. So that's going to be negative 2 times the absolute value of 0 plus 1. I should have made this table bigger. That's okay. That's equal to 1. So we have the point over 0, up 1. All right, let's plug in a few more values. Let's go back one. Let's try negative 3, negative 2, negative 1, 1, 2, 3. That looks like some nice values to try. All right, go ahead and let's plug in some of these guys. So negative 2 times the absolute value of negative 3 plus 1 equals, well, the absolute value of negative 3 is 3. So that's negative 2 times 3 plus 1, which is negative 5. So that tells me -3, -5 is a point on this graph. We have -2, absolute value of -2 plus 1. So that's -2 times 2 plus 1. So that is -4 plus 1, which is -3. And you can see that compression change. -2, absolute value of -1 plus 1 equals -2 times 1 plus 1, which is -1. All right, so there's my graph on the left-hand side. Let's try some positive values. These will be a little bit easier because we don't have to worry about returning absolute value. So this is -2, absolute value of 1 plus 1, which is equal to -1. We have -2, absolute value of 2 plus 1, -3. And we can see that it's symmetric here. And so I'm just going to go ahead and tell you that this is -5. All right, so there's my graph of my translation. Oh, I think I messed up. I did. I put that at the 3 and 4. Let's put that back here at the 2 and 3, shall we? There we go. That looks better. That's why you always use something that can erase to do your work. All right, so here's two different ways of doing transformations. The first one was pretty straightforward. We didn't have any stretching or compression or anything. So we just go ahead and shifted the graph right 2 and down 3. The second one was a little more complicated. We figured out what we thought we were going to see, which was a horizontal compression, shifted up 1 and a reflection, which is what we got. But we decided to use a table of values to help us graph it, make it a little bit easier on ourselves. All right, now we're going to try and use our same skills with function transformations and see if we can write a function of the given graph. So the blue graph, again, that is my g of x equals to absolute x. Let's see if we can write this function in terms of the other one. All right. Pause the video and give it a try, and then we'll come back and do it together. All right, did you figure it out? Let's see. Let's write down what we notice. Well, we notice the first thing I notice is that it's shifted to right. And the other thing I notice is that it's flatter, right? It's been stretched out horizontally. All right, and it looks to me like it's a factor of 2 for the horizontal stretch, because I can see what used to be this change is a stretch from 1 to 1, and now that takes me twice as long. That takes 2 units to get to 1 there. So I'm going to guess that's a stretch of a factor of a half. So I think that this function g of x, or f of x, is equal to my original absolute value function, g, and I want to shift it right to x minus 2 times 1/2. So how do we check these? Well, to be honest with you, I think these are pretty complicated. And this is actually one of the most, I think getting all these translations, especially the vertical and horizontal compression and shifting just right, is one of the harder topics that we do in college algebra. So one thing that I like to do is I like to check my work using Desmos. Desmos is a great tool. And so what I'm going to do is I'm going to show you right now how to check your work using Desmos. All right, here we are in Desmos, and we're going to check our answer. First thing we're going to do is we're going to graph g of x equal to absolute value of x. And the way you do that is you just type g of x equals, and you just start typing ABS. That stands for absolute value of x. All right. And I think it was blue in our original graph, so let's go ahead and make it blue. Awesome. All right, and then we thought our answer was, what did we think the answer was? I'm trying to click back, but it's not working. 1/2 g of x minus 2. So what's great about Desmos is actually you can just type in 1/2 g of x minus 2, and it will take your original function that you have defined above it and do these function transformations. And we can see that that is exactly what we saw graphed originally. So Desmos is a fantastic tool. It's really great. I wish I had this when I went through algebra. All right, so what we're going to do now is we're going to try and do another problem. The problem we're going to try and do is we're going to try and figure out the function that will shift the absolute value function right 2, reflect it horizontally, and down 1. So see if you can write down right now the graph that shifts right 2, reflects horizontally, and shifts down 1. All right, so we already have right 2 going, right? So that's g of x minus 2, right 2. If we want to reflect horizontally, we have to put a negative sign out front. There we go, reflect down horizontally. And if you want to go down 1, subtract 1 off the end. And there is our new function. And I really encourage you to try it by hand first and then check it in Desmos to just verify that you're getting your translations correctly. All right, well, that's the end of this video. The next video we'll start in solving absolute value functions.